One, two, three.
What's up, team? We're going to do a walkthrough of the right triangle altitude theorem. This is genuinely one of my favorite types of problems to solve. I know I'm weird, but it is what it is. So right triangle altitude theorem, as expected by the name, we're going to be working with right triangles. And if you drop an altitude inside of a right triangle, so all that is, as a refresher, is that it's a perpendicular line to the opposite side that goes through the vertex of the right angle. So the theorem basically says that if you have an altitude going through a right triangle, what you've created is three similar right triangles. So there's the small one that's down here, there's the medium-sized one that's hiding up here, and then there's the large overall one. So with those three right triangles, what I'm gonna do and encourage you to do the same is to draw them out separately, fill in the pieces that you know, and then use what you know to try to create some ratios using what we know about similar polygons in general. So first thing I would do is I would name all my vertices. So just to keep things straight, this is our A, we'll call this B, we'll call this C, and this point down here we will call D. So our three similar right triangles, we have three sizes of them. There's the large overall one that we've named A, B, C. There's this medium one that's kind of reflected around. So the right angle is down here at D. The long side goes up to A, and then the short side goes over to B. So this thing, it fits right here, but it's rotated, and I've moved it down. I've just kind of taken the medium-sized one out. We're going to do the same thing with the small one, D, B, C. The right angle, again, is at D. The long side, in this case, goes to B, and then the short side goes to C. So we have three similar right triangles at this point in time, and we're going to fill in what we know. So this X and this 4, so the X is the distance from A to D, so we're going to find all of our ADs. It looks like there's an AD here, and I don't think we have any other ADs going on. Okay. How about DC? DC has a length of 4, so that's that length there, and that is all. Okay. How about BD? BD, we see here, has a length of 6. BD, we also see here, has a length of 6. So notice it serves as the short side of the medium triangle, but also the long side of the small triangle. And we can see that from our, kind of our puzzle there. Okay, another one I suppose we have, it's a little awkward. AC has this length, that's our hypotenuse for the big one, has this length x plus 4. I'm not sure how helpful that will be, but it's true. I think what we're going to end up doing is focusing on the medium and the small size triangle because we have two pieces of information for each. We know if we have any two similar polygons, the corresponding side lengths are going to be proportional. So we can just set up a proportion here. We can say that, there's a few different ways we can set it up. We can do x over 6 equals 6 over 4. We can do 6 over x equals 4 over 6. There's multiple correct ways to do this. Check out the video for the similar polygons if you know this isn't making a ton of sense, this particular step. But I'm just going to work right through it here. So I'm going to do x over 6 equals 6 over 4. And then we just solve for x. So cross multiplying, 4x equals 36. Divide both sides by 4, and we recognize that x equals 9. That's it. The key piece here is recognizing that the right triangle altitude theorem says that this creates three similar right triangles. We kind of extract them from the original image, draw them out separately, make sure to fill in the pieces, the information that you have in the right spots. And then from there, doing this part is pretty simple. Let's do one more. This time the altitude of the large triangle is our unknown, so that might make things a little bit wonky. First thing I would recommend doing, again, is naming all the parts. A, B, C, D. Then I'm going to draw out some triangles. I have a larger right triangle, a medium-sized right triangle, a smaller right triangle. When I draw out my right triangles like this, I encourage you to orient them all the same direction. So you might have to like kind of twist them out of here or whatever to make it make sense for you. But once they're in this state, kind of like we had over here, it's really easy to set up your ratios. So our big one here is A, B, C. Our medium-sized one. So I'm going to start with the right angle, which is at D. And then the short side goes to B. The long side goes up to A. The little triangle down here, this one, the right angle is also at D. The short side is going to be to C, and the long side is going to go up to B. That one's a little confusing because CD and BD look about the same. If the image that you get on the quiz is going to be a lot more clear, this is just a hand-drawn thing. The one on the quiz is going to be computer-drawn, so it'll be a little more clear. Okay, let's fill in what we know. We know that CD has a length of 20. So CD, that's right here, there's a length of 20. We know that DA has a length of 25. That's this here, 25. And really, we also know that AC, that's the entire side here, has a length of 45. So let's go ahead and fill that in. May or may not be helpful, I don't know. And then BD has a length of X, that's this one. BD is also over here. Okay, similar to the last one, we're actually not even going to use the information from the big one because there's only one piece of information. We only have one side length. So that ends up not being helpful. We have two pieces of information for each of these two triangles, however. So we'll set up a ratio. I'm noticing they both have x's. That's okay. It's actually kind of helpful for us. We will see how this goes. Curious how this is going to shake out. Okay, so I'm going to set this up. 25 over x equals x over 20. Cross multiplying x squared equals 25 times 20. Is that 500? Something like that. Got my calculator. I don't want to screw it up on the video. You know how that goes. Yeah, it's 500. So x equals whatever the square root of 500 is. I don't think that that's a perfect square. It ends up not being a perfect square. So it ends up being 22.36 rounded to the nearest hundredth. So this length here is 22.36. That makes sense looking at the information we have. If the long leg here is 25, the short leg must be less than that, and it's in the same ballpark, but it's smaller, so that works. In the same way, the short side here is 20, so the long side must be larger than that one. Cool. It all checks out. We've done it. Right triangle, altitude theorem. The kicker is to recognize that if you have an altitude of a right triangle, it creates three separate similar right triangles. Draw them out. That's hard. It's really hard to do this type of thing in the air. If you're the type of person who's like, oh, I can do it all in my head, I advise you not to. I mean, you're welcome to, I guess. It's fine. But do keep in mind, I know I say this a lot and it's annoying and you roll your eyes at me, but I've literally been doing this longer than you've been alive, and it's not something I do in my head. So I'd advise you to draw it out. Okay, let me know if you have questions.